Okay, so here's another fluid statics problem, and in this problem we have an inclined wall, and we want to know what the resultant force on that inclined wall will be. So to solve this problem, first we have to understand what's going on this inclined wall. And as you can see here, here's like a diagram of an inclined wall. And these arrows show the pressure distribution on that inclined wall. So this one doesn't go all the way to the surface like our problem, but it still gives us a good representation of what's going on. So as you can see, as we go down in depth, pressure will increase. That's why this arrow is longer than this one, because it's at a deeper depth. So to find the resultant is at the average pressure location of this area. So this equation right here, so this point right here, this is the average pressure location of that area, and the area I'm talking about is this rectangular area right here. So the resultant is right about, looks like it's right about here. That's the location of R. So once we have that, so now we find the average pressure through this formula right here. And that's exactly what I did. So average pressure is 1/2 rho g h1 plus h2. h1 is at the 0 location if we denote sea level as 0. So h1 will be 0. And then h2 is 4 meters from the 0 location. So h2 equals 4. And so we get an average pressure of 19,620 pascals. So once we have that, all we need to do now is plug that into our final resultant equation that we found here, circled in pink. And so we're going to need to find the area of this pink outlined area. So first we're going to need to find this height right here, also denoted in the side view right here in the pink, and we find that through Pythagorean's theorem, and we find it to be square root of 41. And so once we have that, we know the width is 4, so 4 times square root of 41 is right there. So that's our area, and then we have our average pressure. And our final answer will be 5.025 times 10 to the 5th newtons.